Okay, one thing about baseball is it has a lot of odds and a lot of probability that goes on every time a pitcher faces a batter in a game. All right. And what we're going to do here today is we're going to learn percentages around the probability of different results coming from a player. So here we go. We're going to start out with Ted Williams, a splendid splinter, 1953 season. And if you're not aware of Ted Williams, by the way, this card we're looking at is amazing as far as the ability to get extra base hits. But Ted Williams, one of the all-time great hitters in Major League history, even though you may not have heard of him. All right. So we're going to just use a sample situation where we're going to say it's bases empty. Now, obviously, we have 8 different scenarios, bases empty all the way to bases loaded on our result boards or our booklet, a result booklet. So I'm just going to keep it simple and just use a bases empty situation. All right. So against a grade D pitcher, what are the odds that Ted Williams is going to get a hit? All right. And what I'm going to do is I'm going to go through his card. Now, every card has 36 results, right? Red die 1, white die 1, all the way through red die 6, white die 6, 36 different possibilities. So I'm going to count against a grade D pitcher every potential hit. Anything less than a 12 is going to be a hit against a grade D pitcher. So if I count here, I'm going to go 1, 2, the number 1, the number 7, the number 1, the number 4. That's 4 hit possibilities. Starting with 31, 5, 33, 6, 35, 7, 42, 8, 44, 9, 51, 10, 55, 11, 64, 12, and 66, 13. He's got 13 hit possibilities out of 36. So he has a 13 out of 36 possibility. And I'm going to get my Excel spreadsheet out here. And 13 divided by 36 is 0.3611, repeating. So move the decimal place over twice. He has a 36% chance of getting a hit against a grade D pitcher. Now, in baseball terms, that's pretty good chance. Okay. Now, I wouldn't say that's his batting average against a grade D pitcher because there are walks included in there that might decrease his number of at bats. All right. Okay. Grade B pitcher. Well, we have the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have the 13 hits against the grade B pitcher. What can we throw out against a grade B pitcher would be anything with a result of 8. And if I count the number of 8s up here, this is a bases empty situation, right? Because against a grade B pitcher in a bases empty situation, an 8's going to be an out against a better pitcher. So I've got 1, 2, 3. I've got 3 8 results there. So I'm going to subtract that from my 13. I end up with 10. 10 out of 36. Against a grade B pitcher, he has it with the bases empty, 10 out of 36, or 0.278, actually 277 repeating. If I round that to the nearest percentage, he has a 28% chance of getting a hit. Now, how about against a grade A pitcher? Okay, very good. Grade A pitcher, I have to throw out all of the 9s. There are 2 9s up here, correct? I already threw out my 8s. Against a grade A pitcher, a 9 is going to be a strikeout. All right? I've got 2 9s. I'm going to subtract that from my previous 10 hits. Because a grade A pitcher, he has an 8 out of 36 chance of getting a hit. And if I run that, I find that his calculation is going to be, ding, 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 8 divided by 36 Am I getting August of 8 divided by 36? 0.2 repeating or a 22% chance. All right. Now, his odds of getting an extra base hit will be the same against all of our different pitching grades because A pitcher nor a D pitcher can stop an extra base hit. Well, how many extra base hits are on here? 11, 1, 22, 1. Well, I should say 22, that's the second base hit. 33 is the third extra base hit. 44 is the fourth extra base hit. 55 is the fifth extra base hit. Anything 6 or less is going to be extra base hit. And 66 is a 1. That's another extra base hit. He has 6 different possibilities of an extra base hit on his card. 6 divided by a total of 36 dice rolls equals 0.16666, which as you can probably see is going to be a 17% chance. Which means 1 out of every 6 plate appearances, he's getting an extra base hit. Now we're looking at one of the outstanding performances in a year for Ted Williams. In fact, we might need to Google and look and see what his stats were. That's amazing. Finally, what are his odds of hitting a home run? Well, here we're limited with bases empty. Now you can't hit a home run with a 6, I think, with a runner on third. With bases empty, it's just going to be the 1 result. 1, 2, 3, 4. He has 4 ones. 4 out of 36. That's going to be 0.11 beating. He has still an 11% chance of hitting a home run. Now, in terms of home runs hitting, that is really good odds. That's one of the all-time greats. Okay, now I just have to do an aside here. 1953. Let's look up Ted Williams stats here. Baseball Reference. I just have to look this up. This is just nuts, okay? And again, baseball is all about statistics, okay? It's kind of crazy. All right. But if we go look up, and I have no idea why this bar popped up here. Get this out of here. Thank you. Go down and look at 19. Why is my screen so weird? This usually doesn't happen. Hello. My screen is whacked out. Whacked out. Why am I getting pop-up ads? I have no idea. Get those out of here, please. I'm trying to see the left side of my screen. Ad choices. Close. Ad choices. Oh boy, I don't know. Anyway, it's not playing nice in the sandbox here. 44. I gotta get rid of this thing. It's killing me. There we go. That's better. 1953. 1953 Ted Williams. Well, now things come to light here because he didn't have a whole lot of at-bats. He had a grand total of 91 at-bats, for which he hit 13 home runs and hit 6 doubles. Sounds like he was possibly injured or had war service that year. Okay. I thought it was going to be some big, like all these extra base hits. He batted .407, but he had a limited sample size, but that was reflected in his card. 13 home runs and 91 at-bats. 110 plate appearances. So he had a home run like every 9 plate appearances. Thus, 1 out of 11 or 11% are his odds of hitting a home run. Isn't this fun? I just love stats. Okay. Now let's take a look at Jose Abreu. 2020 season. Now we've just did some calculations for Ted Williams. I don't want to repeat those all over again. But grade B pitcher, what are his odds of getting a hit against a grade B pitcher? We can't include 8s. So anything 11 or less, not including 8, is going to be a base hit. So count with me. 11 is 1. We count 15 because that's going to be an out against a grade B pitcher. 22 is 2. 25 is an 8. We can't include that. 31 is an 8. We can't include that. 33, that's 3. 35, 4. 42, 5. 44, 6. Can't include 51. 55, 7. Excuse me. And 66, 8. 66, 8. Okay. 8 out of 36 equals, whoopsie doopsie doo. I just lost it there. Thank you. Where'd my Excel spreadsheet go? Bink. Okay, over here equals 8 out of 36. That's 0.22, 22% chance of getting a hit against a grade B pitcher. How about an extra base hit? Well, good question. Now, here we've got some different probabilities going on. We have to start with our first column. What are the odds we're going to get a hit in the first, an extra base hit in the first column? Well, here we're only counting our ones. I've got a 1 here. I have a 1 here. 2 out of 36. Okay. Now here's where it gets tricky. How many zeros does he have on his card? He has 1, 2, 3 zeros. 1, 2, 3 zeros. So we would say he has a 3 out of 36 chance, 3 zeros, of getting extra base hit. Well, now we go to the second column. Again, in the second column, he's most likely going to get an extra base hit. But how many non-extra base hits do we have? Well, if I look at this, I've got 12 is 7. 32 is 7. 52 is 7. I see 3 7s in his second column. Everything else is going to be a home run, a double, or I should say everything else can be a home run or a double. I don't see any 2s for triples up there. Okay. So 3 7s. So we would say he has assuming he goes to the second column, he has a 3 out of 36 chance. That's a lie. A 33 out of 36 chance of getting an extra base hit in the second column. Oh my goodness, Reardon, what are we doing? Well, let's do the math. What's 3 divided by 36? That's the odds he's going to get a 0. Times 33 over 36, the odds he's going to get an extra base hit in the second column. Well, let's do the math. What's 3 times 33? That's going to equal 99. Divided by, what's 36 times 36? 1296. Multiply your fraction, 3 over 36 times 33 over 36. What is 99 divided by 1296? I come up with 0.07638, blah, blah, blah. Or he has approximately an 8% chance of getting an extra base hit. All right. And again, we could figure out home runs to, wait a second, that's not true. Let's back up. I forgot my 2 out of 36 over here, didn't I? Oh no, equals 2 divided by 36. That was 0.0555 repeating. Change my answer because this second thing that I calculated was just with the zeros. The first one was with the home runs, 2 out of 36. So now I've got 0.5505 repeating plus my 0.076 so on down there. I've got 0.3131944. Round that to the nearest percent, you can probably see he has a 13% chance, or approximately like 1 out of 8 plate appearances of getting an extra base hit. All right. So you might want to go back and review that again. We'll go through this in class. If you missed the class, this is the lesson on probability. And during our games today, we will be calculating a couple times based on whoever the batter is, based on whatever the base situation is. We're going to be calculating what the odds are of them getting an extra base hit or some other factor. Hey, you're facing a grade A pitcher. What are the odds of getting an extra base hit this next at bat, or a home run, or whatever? Some players will have single column cards. Some players like Jose Abreu will have double column cards. All right. So there you go with baseball and percentages. Take care.